Here is show the turning lathe actions of the CNC router machines by using a 6-axis. And I can individually set the rotation speed of this 6-axis. Now rotate slower. Faster, and I can approach the tools by the lathe cutting tool by using the y-axis. Here I fit it very slowly. I increase the fit rate so you can see it here. Wait for a moment. Okay, I can move the tool in my direction. Because they are moving at two different fit rates. And on the 5th axis, I use the individual pulse, while the X, Y, Z axis still using the pulse from the Mark V. And here I show you guide. Here is the panel of the modified control box. Here is individual pulse speed setting here. Here I choose the 5th axis using the individual pulse. When I hit it down, it use the Mark III pulse. It will be used in control mirroring, etc. When I turn it upwards, it will be used for lathe turning action. And this is just a on-off button for the 5th and 4th axis. Thank you for your watching. Here is the pulse generator, and this is the switch for choosing pulse from pulse generator or from March. And I'm going to install it into the electronic controller box. Here in the box panels, I drill 2 holes for them. This axis has a turning operations. You have to use a fast fit rate on it, and the fit rate will be different from the original 4th axis or X, Y, Z axis. So it's not possible to set 2 different fit rates on the Mark III. So you have to make another separate pulse generators for this 5th axis if you want to use this axis as a turning operation or process. Now I make the pulse generator. And I can change the fit rates with the knob. Brown color circuit boards with the variable resistor. Here is the circuit board for the pulse generator. You can see there is a capacitor here. For this capacitor is for changing the time constant together with these two 1, 2, 3 variable resistor, and the timer IC is the ordinary one, LM555 here. The circuit is very simple. Hello, here is the circuit for the pulse generator, and it is a very general circuit, and you can Google these circuits on the internet, and this R1, R2, and C, these three values will determine the frequency or the periods of the pulse, and the formulas of this you can find it in Google's. And also for the pulse change, we need to know there is the duty cycle. The meaning of the duty cycle is T1 over T. T1 is the positive pulse width, and T is the total times for the pulse, the on time and off times, and the duty cycle is defined as the ratio of the positive pulse intervals and the total times or the periods. And this duty cycles, there is also the formulas on the internet, and you can find it. And this duty cycle and also the frequency of the pulse depends on these three values, R1, R2, and C. And in usual case, we set this. We use a variable resistor for this 10k ohm, and we use a fixed resistor for these two. But in my circuits, I make these two resistor also as a variable resistor, so I can variable these two values to have a variation of the duty cycle. And after you fix these two values, you can insert a fixed resistor for them. And this capacitor, I use a 0.047 mil. And here you can see the scope. I first turn it to set the frequency. And I vary one of the E2's variable resistor. You can see the frequency change also, and also the duty cycle will change as well. And you have to set it until to have a even duty cycle. Here is about 15%, and it's okay. You can see here it's more than 15%. And you turn to anti-clockwise. You see the duty cycle become lesser.